Morning, guys and girls. If there are any in the room, this morning's subject is not one of the most glamorous ones, but it's one that, for some or the other reason, plumbers keep either forgetting or keep getting wrong. So let's dip straight into it. We're talking about access to drainage systems. It is not rocket science, but in most cases where we've got qualified plumbers signing off jobs or signing COC or ticking the box, if you want to call it that, for the drainage bit, we do find problems here and there. To the guys that actually pay attention, thanks for that. But let's have a quick look at this. There are four main means of access to a drainage system. Inspection chamber is not deeper than 1200, and it does not have to be big enough so someone can get into it. So it's basically exactly as the name says, an inspection chamber, or the next one is an inspection eye, would be an access on to the interior of the pipe or the fitting in an installation provided solely for the purposes of inspections and testing, and to which permanent access need not be provided. So those are the IEs that you see on the IE junctions and straights and bends underground, just for the torch, the mirror, the CCTV or anything like that. That's what they intended for. A manhole is a chamber of a depth greater than 750 and such dimensions to allow a person to actually gain access. So as per the name, you'll see that a man needs to get into the hole. A manhole would be the one that you need to be able to get into. An inspection chamber is exactly that. It's just a chamber. A rotting eye is a access opening in a drainage installation provided for the purposes of gaining full bore access to the interior of a drain for internal cleaning, and it remains permanently accessible after the completion of the installation. So we keep those four things in mind. They are the different options. Then we look at SANS 10400 Part P, which is the extract or the portion of the National Building Regulations that the BCO used to assess your drainage. And it is very clear. The following requirements shall apply with regards to access to a drain. A drainage installation shall be so designed and constructed as to permit adequate, take note, adequate access to the interior of a pipe in such installation for the purposes of inspection, testing, and internal cleaning. The inspection and testing, obviously, while the job is on the go, but once it's handed over to the owner, you do not want the guys doing the maintenance coming in there, digging up a yard like a dog looking for a spot to find to bury a bone. These things should be accessible. They should be indicated. Where a discharge pipe enters the ground, adequate means of access to the interior shall be provided within 2 meters above the point of entry. So when you look at a stub stack, you've got a IE cap or an end cap that can screw off, or you could take it off and gain access. If it's a single stack going up to the first and second floor or story, then you need to provide access within 2 meters so you could actually get into the drain from that stack. Where a drain or discharge pipe passes through a room, which is used as a kitchen, pantry, or for the preparation, handling, storage, or sale of food, the means of access to the drain or pipe for cleaning purposes shall be situated outside such a room. For obvious reasons, you do not want an open-ended connection to the kitchen from the drain. And then with the proviso that the requirements for this shall not apply in the case of a waste pipe serving a waste fixture contained in such a room. A perfect example of that would be, there is a standard detail or a commercial kitchen. Figure 3 in 10252 Part 2 shows you where you're allowed to have junctions and connections into the drain from that kitchen, but at no point they're allowed to be open. The access opening to a drain or discharge pipe installed within a building shall be covered by an adequately screwed or bolted airtight cover, for obvious reasons. A rodding eye or manhole shall be installed where there is a change of direction on the drain that exceeds 45 degrees, provided that where a bend that has a centerline radius of not less than 600 mm, in other words, a proper long radius bend, the rodding eye may be omitted for not more than 2 of those changes between any rodding eyes in terms of 2, 3, and 4. So if you do have a long radius bend at the foot of a stack and you need another long radius to get out, there's your 2, or to change direction to the outside, there's your 2 bends. So you can omit in the case of those long radius bends. At any point within 1.5 meter off the connection to a sewer, septic tank, or conservancy tank, provided that an IE shall be installed immediately downstream. So we need to test, or we need to gain access for the CCTV or for the inspection. It'll be provided downstream from that connection rodding eye. At the highest point of the drain, at such intervals that the drain has no rodding distance more than 25 meters measured along the line of the drain, from the rodding eye or any other permanent access on that drain. And as far as the rodding eyes are concerned, a rodding eye shall join the drain in the direction of flow at an angle of not more than 45. It will be continued up to the ground level and adequately supported. For the guys that have been in the business for a while, you would remember that early days when you did an inspection, if there weren't any concrete surrounds around those rodding eyes, they would come back at a later stage to see it was actually done. Then be adequately marked and protected. The protected can have a concrete surround, but marked, or at least at a level where the next guy doesn't have to dig up the whole property to get to those rodding eyes. The access contemplated in 419.1, which is the previous slide, subject to the requirements contained in 7, which is still on its way. Any permanent access which is covered by any paved ground shall be covered, or any permanent access, which is covered by a paved area or ground shall be covered by an adequate and appropriately marked removable device. Where there's a drainage installation pass under a building, access shall be provided to the installation outside of and as near as possible to the building at each point of entry to or exit from under the building. So if we do build over a drain, we provide access on both sides. And then, very important, no access shall be provided from within the building. The lid covering the opening, which gives access to the installation, shall be sealed, that the lid will remain effective under all working conditions. So you don't end up buying a PVC rodding eye cover and putting it in a trucking yard or a driveway. It needs to remain effective under all working conditions. Any means other than a manhole or an inspection chamber provided for access to a drainage installation shall have a removable cover designed and constructed that it will sustain any normal load, and it will exclude the ingress or egress of water. It's not a stormwater drain point, and it is definitely not an emergency overflow for when there's a problem with the drain. So the other means, in other words, your rodding eye covers or your point or your bolted covers, ingress or egress of water, both of them not allowed. Be of a size and a shape to permit ready access to the installation for the purpose of inspecting, testing, or cleaning, as the case might be. And then within a building, be constructed that to be watertight when subjected to a maximum internal water pressure of 50 kPa. So 50 kPa is around, when you're plunging on a block drain, you wouldn't want the thing to be pouring water all over the place. You'd want it to be closed and tight so that whatever pressure you apply goes onto the blockage and not leaking out of all types of openings and holes. A manhole inspection chambers will have a minimum planned dimension of not less than 450. There are, when you look at the red book or you look at the engineering design setup, you'll find that there are depths that you work to. If once you go past a certain depth, then you upsize and you end up with a 1050 or a 1500 concrete ring, but never less than 450. located in an open air space. In other words, you don't build or you can't build over a manhole. Be constructed and covered as to prevent the ingress of water and of sufficient strength to sustain any load that might normally be imposed upon it. This note that was stuck in here is as with regards to plan approvals. An open air space should not be taken to preclude location under the roof of a carport or any similar well-ventilated area outside the building. The guys doing maintenance, they would have run into this regularly. You get to the older houses, they all had these stoop areas at the back, was 1.5 meters, 2 meters wide, and all the plumbing was under there. It ended up in a manhole. What they normally end up doing is you're taking the total of that floor area, and if the opening on the outside with those columns or the little stub wall, if that opening is 60%, it's classified as open and it's properly ventilated, then it should not preclude the positioning of the manhole under that portion of the roof. Where the connection between two sections of a drain are at a different level that necessitate a steep fall, the change in level shall be effected by one or more 22.5/16 bends, which shall be connected to the shortest possible length of pipe, connected in turn through 1 or 2 more bends to the lower drain. In other words, an offset. We'll have an example of that coming up shortly, but basically you need to have as long a radius with as short a piece of pipe between those two sections of pipe. Maximum spacings. Between rodding eyes, we've already seen not exceeding 25 meters. And manholes, that's on internal domestic drainage, 45 meters, so that you end up from the one manhole to the other manhole. You should be able to get in from both ends of that. So these are deemed to satisfy. They're safe enough to work on that. If you do have bigger ones or you have bigger distances and it was done by a competent person engineering, then by all means, that's what you put in. But as far as deemed to satisfy on a normal domestic, we try and stick to these sizes or to these distances here. Okay, so now we look at some of the problems that do crop up, or the issues that do crop up when it comes to unsupervised or a drain layer left to his own devices. You can see it would have been quite easy and a saving if this thing was done properly with a Y junction and one of these bends going out. You could have saved that. And you'll find in most cases it works out like that. When you do something that's wrong and it snowballs, you end up finding using more material, you've got more excavation, you've got more this. The shortened or the straightest, shortest route is normally the one that keeps you going. So that had to be moved. Those are not 600 diameter. Those are just normal. You can see there's no difference between the S&V and the underground fitting. So good luck to the guy that comes along and does maintenance on an IE cover to start off with instead of a stub stack, and then having to force his way through these two 90 bends and then end up in a 45 and a Y junction somewhere else. Not acceptable. Here's an example of a backdrop. If that junction had been repositioned where it's supposed to be and the other end going up for the access, that would have been a spare bend, so that's less material. And by going through 45, 45 and 45, you're doing 3 bends instead of just going down one, or going down the junction and into the bottom one there. So instead of rolling through one, you end up going through 3 here. And then one of the ones that I see quite regularly, I don't know how they got to this, but same thing applies. Y junction in here, rodding eye out in the straight, that gives you access down that line. Access from this line would have been from the other rodding eye. So instead of going through 1, 2, 3 bends, could have gone through 1. And this is something that the maintenance guys come across regularly. Never mind the vent-on bend in the background there. You've got one plastic rodding eye here, You got a fitting there, you got a gully there, there's no access provided down that alley there, there's nothing on the side here. So you get to site for a block drain and you look at this cover and you're not sure whether this thing is running towards you, away from you, towards that drain there. No access, no indication, one rotting eye on the whole premises. And then when it comes to the bolting down, you'll see these are all little single seal covers. These should have had bolted airtight covers. You could still have that if you had the normal cover in there, but you can see this thing, even with the paving and the grouting, is already sand going in there. Same over here. You've got a nice cover there so you can actually find it, but there's smell coming out of the single seal cover. It's not watertight. So if there's any pressure on this, you'll probably find that if you plunge further down or further up the line, then you'll probably find that this lid starts jumping up and down with the pressure being applied from the water. An example of what it should not look like. This one here was left in Port Elizabeth for just under a year, and the sun got hold of it. And if you consider that PE is actually moderate coastal temperature, I'd hate to see what that thing looks like in the Karoo or up into the more drier, hotter areas than what we are. And see that's what it was. And that piece was saved because the grout that the paver the paver used actually covered this little bit. So it went from that to this in less than a year. Another example, beautiful white, supposedly the same material than a soil and vent. And you can see it's starting to go, it's starting to crack, and this was not in a traffic area, this was foot traffic only. And you can see it's already starting to show signs of disintegrating. Here's another one where someone was left to do his own thing. Good luck with the access into that. Never mind the fact that your junctions, well, it should be Y junction and a 1/8 bend. Yeah, I'll just leave it at that before we use language unbefitting. The fact is that you can't have that access through a 90 or a 90 or a 90 or anything. That whole thing should just be left by saying nothing. And then we find this quite regularly. It's nice and compact. Only way to fit it in, sir. But it works until the poor maintenance guy comes along and he can't get a rod through there or through that soil and vent bend there. And then this waste pipe disappears under the ground from the house and it ends up going around and it ends up going into a reducer in that 45 bend there. So couldn't clear the blockage, opened the whole thing up, replaced with this material here, left side blockage occurred again, next plumber come along, and this is what you're stuck with. So as far as access is concerned, guys, it's straightforward. Show the places where it's required. It always refers to full bore access. It refers to slow or long radius bends. If you stick to that, there's no ways that you can go wrong. Sounds simple enough, but yet these things do get failed, and I don't know if it's a lack of supervision or something being covered up before the next guy comes along. But ultimately, further down the line, it all boils down to if you're going to be leaving jackpots for the maintenance plumber that's coming in after you, then you should be expecting something similar when you get to another job. So if we're not in the business of making each other's lives miserable, so it could have been a straightforward job that ends up digging, and by the time the project or by the time this blockage becomes a project and you end up invoicing the client, the invoice gets frowned upon because, it should have been straightforward cleaning the block drain, and now you're charging me a fortune here because you had to fix something done by some other. And let's face it, there are some pipe fitters out there. We're not in the business of competing or condemning other people. But if you're a pipe fitter and this is what you leave behind, you shouldn't be doing plumbing. Sorry about getting onto my soapbox, but that's pretty much it. So, are there any questions?
Yes, indeed, we do have a couple questions here. I'll get right into them. The first one reads, Morning all. Is it still a must to install a service vent on a sewer system if vent valves are being used?
Yes, indeed. One of the slides that we touched on 2 weeks ago was that every installation shall have one open vent. So the vent valves are considered auxiliary, or you could they dealt with under open vent, but the standard clearly says that you shall have an open vent on every system.
All right, the next one is, how deep should a septic tank / trench should be?
From experience, you're looking at minimum gradient on the pipe flowing into that septic tank, bearing in mind that the depth of the septic tank gets determined by the actual inlet to that tank. So if your inlet is a meter deep, that means that whatever you're building onto that, or whatever you're adding on as far as the septic tank is concerned, starts at 1 meter below ground level. So you get minimum gradient, and you try and get in there as flat as possible so that you don't end up with a 3-meter excavation for a septic tank, because the soakaway has got to go even lower than that. So you try and keep it as flat as possible. So I think the standard refers to minimum gradient.
All right, the next one. How long would a septic tank last if it cater for 5 in the rural area?
Okay, I'm actually trying to open it up while we speak. If you look at SANS 10400 Part P that deals with the drainage, you'll see that they actually have a requirement that when a tank is installed, that you need to go, before the tank is even built, you need to actually have a look at a couple of things. There's a sewage flow from buildings, and you've got to allow for that, the rate of sludge and scum accumulation, and then the most important one that they deal with, there we go, in situ test pit and test hole. So if I could refer the sender of that question to page 50 in 10400 Part P, that says that you need to dig a hole 300 by 300 by 300 by 350 deep, or between 300 and 350 deep, and you end up filling it with water. And see, there are areas that where you put in a septic tank, for argument's sake, in sandy soil, that would actually go down and disappear. Then you get the ones like we have areas here in Port Elizabeth where they have semi-clay type soil. You end up going shallower and wider. And funny enough, one of the things that is mentioned in a study that I read a while ago is that if you go shallow and wide, the sun and the wind, especially in PE with the wind actually helps to dry out that soakaway. So the expected life of that tank should be forever. It's the soakaway that might become a bit of an issue. And somewhere along the line, if there's a hassle, or there's the thing stops working or it fails, most of the time they end up digging a new soakaway, and Bob's your auntie, and that tank will just continue working.
All right, perfect. The next one reads, do we have to drain the septic tank during the time, or after how long?
The section I just referred to as far as the sludge accumulation is concerned, I've actually had it open just here. What happens is that while you're doing the sludge accumulation, it says here, rate of sludge and scum accumulation in dwellings with multiple fixtures. The rate of scum accumulation on a normal, water and soft toilet paper, additional household sewage is 40 liters per person per year. So yes, you do get to a point where you have to end up taking, or you need to get rid of the scum at the bottom, or the sediment at the bottom of that tank, because remember, it breaks up, the septic tank breaks up the sewage into a liquid, or into a substance that the solids will end up going down and the water would go out of the tank. So at 40 liters per person per year, so if you have got 5 people in the year, that means that every year that thing is in use, you'll have 200 liters of sludge down the bottom. So yes, If you only have a 500-liter tank or you have a 1,500-liter tank, you'll have to empty get one of those vacuum tankers to come and empty that thing, and it'll start working from scratch again.
All right, perfect. The next one reads, rotting eyelids. Are we supposed to sands to provide cover to keep them out of the sun, or is the testing of such lids to blame for them being chowed by the sun?
The ones that are tested to a sand standard for that rotting eye cover or that access should have the same material on it than the normal soil and vent pipes. The soil and vent pipes, we've all seen them survive for ages outside the building. So strictly speaking, the cover should be the same material than the soil and vent pipes. The non-compliant ones, the softer ones, or the ones from funny material and that, it's easy enough to ask them whether the thing is actually tested. Other than that, if you know it's going to be an issue or you know it's going to be in a paved area, most of the guys prefer putting up a concrete surround or putting up an additional cover over them, because it ties in. It's easier for the paver to work to a square slab than what it is to the round cover. But yeah, definitely it's up to the manufacturer to make sure that the actual lid of that rotting eye should survive outside in the weather.
All right, the next one reads, when a drain passes under a building, do you need a manhole on either side, or will a rotting eye suffice?
The rotting eye before you enter under the building is acceptable. The issue that normally crops up is that if you provide a rotting eye on the other side of the building, yes, you can clean the line further or away from the building, but you can't get access back. So if it's a short enough building, it's a double garage or something, and you should be able to rod under the building from the let's call it the incoming side. That shouldn't be a problem. And then the access is on the other side. You'll be able to see whether the blockage is actually under the building. So yeah, depending on you need it on both sides. The form of access is up to the plumber to decide if he needs to go under a building that's 40 meters wide, then obviously manholes would be a better bet because you get better access on it. But if it's just going under an extension of 6 to 10 or 12 meters, whatever, you could rod comfortably. A rodding eye before the building should suffice, and then on the other side, if it's just to gain access, a rodding eye would actually work on the other side as well.
All right, perfect. The next one reads, what is your preferred filling materials for French drain? And is it allowed to be covered with a solid steel frame and sheeting when clearly demarcated?
Preferred filling material, I've seen everything from coke crates to bricks to all kinds of funny things. The last one I was involved with, we actually had without doing advertising, there was a K-Tech has got like a dome. It looks like one of these two-man tents that creates a void, and you could actually backfill, or you put the bottom and you can backfill, and this thing leaves you about just under a meter high and about a meter and a half wide. Void where the water can go in there and it can actually soak away at its own rate. So there are various options. It depends on, like I say, the depth, the type of material. If it's a shallow one, the normal, those 19 mil, those big crushed stone, any of those will work. It's all down to the actual soil where you're planning on working or when you have to work. If it's sand and the water will soak away almost immediately, anything would work. If it's clay, then you have to start thinking about putting in something that would actually, because it can't soak away, you need something with bigger opening, or you need something where the water can stream into this thing, lay in this vast open area and be dried by the sun and the wind and cleaned up there. So there's not really a preferred one. Something you can Google off your smartphone, like I say, those K-Tech units. They work quite nice. You dig a trench, you clip them together, you form this huge train of these molds clipped together, put them across, and you backfill them, and they work like a charm.
All right, perfect. The next one reads, horizontal junctions underground. Are access junctions required if there are suitable above ground rotting eyes?
Horizontal junction. Just read that again.
All right. It reads, horizontal junctions underground. Are access junctions required if there are suitable above ground rotting eyes?
I'm assuming the question is around the IE junction itself or the access junction itself. If you're looking
Okay,
at
there's a touch up on that question. It's can plain
okay.
junctions be used?
There we go. I thought as much. See, I'm even starting to think like an old plumber now. Okay, the question is, or the question should be that if it is the top and the first and the last fitting, we need to do the testing. If you're going to be putting a torch and a mirror in there to do a barrel test, or to put your equipment in there to do a pressure test, you need access on those things, and the standard actually says that you need to provide those IE points for the access. When you're doing something like a gully, which you can't rod through, then an IE junction on the line is not a bad idea, because you could actually open that up and work your way back towards the gully. If adequate, and I'm saying this like we're talking about a 92.5 degree IE junction with an screw IE cap on the top. If you're talking about adequate access from there into the line, then a plain junction should suffice, because you'd actually go through that the IE cap, through the 245 bends, and through that Y junction into the main run without any hassles. So I think it'll be up to the individual. Obviously, there's a cost involved, but if you have a house and you have 6 junctions coming down the side of the building, if there's one at the top and the bottom, so you could test the whole drainage run, and there's one at the gully, and the others have got proper stub stacks or proper single stack with an access within 2 meters, and you can rod through those 245s into the main run, I can't see why those can't be plain junctions.
All right, the next one reads, a rotting eye is supposed to be well supported. If we require to concrete the rotting eye in place, or is well compacted soil sufficient?
The well compacted soil is sufficient. The requirement, or let's put it this way, if I can't remember which pipe manufacturer, but if you, I'm thinking it could be DPI, in their installation standard or in their material list and requirement, they actually indicate there that if you're using a 6x4 junction and the thing extends to 45 degrees, they actually do prefer you don't use that, or you allow extra support, because the strain that you're putting on that 4-inch extension might snap the junction down the bottom. And on that same detail, they indicate that you backfill and you ram fill properly compacted soil up to the top, and you provide the concrete surround at your finish level. So yeah, when you're looking at supporting, there's no problem, or there shouldn't be any hassle. I know when you do backdrops into manholes, the requirement is, or the standard detail to those manholes is, that you start from the bottom where those bends go into the channel, right up to the top where the junction goes through the wall again on that backdrop, that those things get encased in concrete. But if it's a normal residential drain, there's no reason why you should backfill the whole thing with concrete.
All right, the next one reads, how far away from a river may I install a French drain / soakaway?
I am going to quote what our sewer master plan and our normal department water affairs here. You are looking at 1,000 meters minimum. So 1 kilometer from any water course, high water mark, riverbed, you're looking at a minimum of 1 kilometer. And even then, on that 1 kilometer mark, they'll tell you that you need a specialized design. So if it's a soakaway, you might have to be further away. Otherwise, that soakaway would have to be omitted, and that septic tank might be required, or you might require that septic tank to become a conservancy tank that gets emptied by honeysucker.
All right, perfect. And the last question for this morning reads, why is an open vent compulsory on any drainage system?
Okay. Each individual site or dwelling or building is required to have an open vent, not only to allow fresh air into that system. If you consider the guys that have done the gas course or that have done a gas course, that your drain fills up with flammable gas. They won't put a gully and a gas bottle next to each other. So that, I think it's methane gas. So it's one of those flammable things that needs to escape in little bits and pieces as the system gets used. But in the same breath, then the combination of all those units next to each other connecting to a municipal sewer, those 50 mil or 110 mil open vents on that system or on the internal plumbing system helps vent the municipal sewer system so that no gas builds up into or in that main. In the next thing you end up, because ultimately you can actually have a case where, I mean, unfortunately we had one 2 or 3 years ago in PE where the guys got into a manhole without opening manholes downstream, upstream. That gas is lethal. The guy got a bit groggy, he slipped down and he drowned in a sewer manhole. So we're trying to get rid of the gas that is building up, or the gas that builds up in the system on in a little bits and pieces way. And like I said, the standard requires an open vent for each installation. The others you can put two-way vent valves if you want to waste that money. But if a system is properly vented, then the need for that two-way vent valve is almost null and void. Because if you're venting the highest point or you're venting all the long branches and that, there shouldn't be any requirement for anything else. But yes, it's very important because you're not only venting your drain, you're venting the whole sewer system. And I think that's just about it.
All right, perfect. Well, that is all of the questions we have got this morning. Would you like to go ahead and end off?
Yeah, guys, keep it safe. Do the right thing. If you do run into someone, or let's put it this way, if you can't behave, take pictures. Let's put it that way. Keep it safe out there, and we'll chat next week.
All right, perfect. Thanks so much for joining us today, guys. I hope everyone enjoys the rest of the week, and I hope to see everyone again, same time next week, Thursday. Thanks so much for joining us. Enjoy the rest of your week. Bye-bye.